Hello friends, this is Priyanka. Today we are going to solve a problem on turning moment diagrams and flywheel. In this video we are going to solve the problem by using some basic equations instead of using complicated formulas. Now first I will read what is the given problem. The flywheel of a steam engine has a radius of gyration 1 meter and mass 2500 kg. The starting torque of the steam engine is 1500 Newton meter and may be assumed constant. Determine angular acceleration of flywheel, kinetic energy of the flywheel after 10 seconds from the start. So this was the given question. Let us first understand the given data. So here radius of gyration 1 meter, mass 2500 kg and this torque is 1500 Newton meter. So this is the given data. Now first question is that we have to find out the angular acceleration of flywheel. So here angular acceleration is nothing but alpha. So if we consider the linear motion, then in linear motion we know that what is the formula? F is equal to ma, where a is the acceleration. But here because the flywheel is rotating, we have to find out the angular acceleration alpha. So how we can convert this formula? So instead of this linear force F, we will use here torque T, which is equal to m, that is we will use here as a I, and instead of a we will use here as a alpha, that is this angular acceleration. So here torque T is given. Now what is I? That is the mass moment of inertia. So here mass moment of inertia is equal to mk square for the flywheel and alpha. So if we put all the values, so torque T 2500 kg, mass m is 2500 and k 1 meter, that is 1 square, and here is alpha. So we can calculate the alpha, that is only one unknown term, and that is 0.6 radians per second square. So this is the answer. Now we will move for the next question. So next question is that kinetic energy of the flywheel after 10 seconds. So here time is given, that is 10 seconds. T is equal to 10 seconds, that is given, and we have to find out the kinetic energy. So what is the formula for kinetic energy? So when we consider the linear motion, then Ke is equal to half mv square, but in case of flywheel is rotating, Ke is equal to half, instead of mi and instead of v angular velocity, omega square. So we have to take omega after 10 seconds, because we have to find out the kinetic energy after the passing the time period of 10 seconds. So we will first understand the graph. So graph is for this angular velocity versus time. So here I will plot angular velocity, that is omega, and here is time t. So if we observe, we require what is this omega after 10 seconds. So we will consider for that at the start point, that is at time t is equal to 0, omega which is equal to omega 1. So here omega is equal to omega 1 when t is equal to 0. And when t is equal to 10 seconds, so as the time is passing, here somewhere t is equal to 10 seconds, then omega is equal to omega 2 we will consider. And at the same time we will consider this angular acceleration alpha will remain constant. So at constant angular acceleration we have to draw here one straight line. So for this straight line here, this is the graph. So at 0 there is omega 1, and then when there is 10 seconds, so if I draw here one vertical line after 10 seconds, then here will be the omega 2. So in this way, what is the formula to calculate this omega 2? So again, if we observe the formula in case of linear motion, so we know one formula, that is V is equal to U plus AT. So this is the formula for linear motion, where V that is the final velocity, u is the initial velocity, a acceleration, and t is time. So how we can convert this formula? So here final velocity, that is nothing but omega 2, which is equal to initial velocity is nothing but omega 1 plus a, that is acceleration a, angular acceleration alpha, and time t will remain same. So we will use this formula. So here I will write the formula. So before that we have to write, let omega 1 angular speed at rest, that is at 0, omega 2 angular speed after 10 seconds, that is omega 2, and this omega 1 and omega 2 are considered with the constant acceleration. So what is the formula we have to use? That is omega 2 is equal to omega 1 plus alpha t. So when we put the value, that is omega 1 is 0, because at time 0 it is at rest. So here omega 1 is 0, alpha that is 0.6, and time t 10 seconds. That is omega 2 is equal to 6 rad per second. So now we know the formula for kinetic energy, half I omega square. So instead of omega we have to use omega 2, because the question is that we have to calculate the kinetic energy after 10 seconds, that is at omega 2. So when we put value, so I value 2500 into 1 square, omega 2 that is 6 square. So here 45,000 Newton meter is the answer.